virtual currency. Okay, so we all know there is something like globally, even in some cases we have seen that the malware which is infected in the recent times, that is the WannaCry ransomware and all. So when it enters into your system through some vulnerable channels and encrypts all the data, after that it asks for to pay some bitcoins in order to give you the keys to open your files. Is it right? So this is the way the underground channel, and even so some of the countries they are legalizing, but in our country the government has decided not to legalize as of now. The idea right now, why I'm trying is not to understand the Bitcoin, but the idea is Bitcoin, which is a virtual currency which is getting widely popular, so is based on this blockchain technology. The underneath technology which is used in virtual currency is the blockchain technology. So in addition to the creation of the virtual currencies and carrying out the financial transaction, there are plenty of other applications for the blockchain. So let us not worry about the Bitcoin, but try to understand the blockchain technology, and you can find the plenty of applications which can be used in the different domains. Okay, that is the aim of our this particular thing. What exactly is a blockchain technology is, it helps you to create the distributed ledger. So how you are trying to create the distributed ledger is, so it is a continuously growing list of records called blocks, and these blocks are linked and secured. See now, when you talk about a centralized repository, see whatever the details corresponding to the various transactions and all, you are trying to maintain a central store. See, there is no way actually where you try to maintain in the time order fashion and other things like that. And also, if suppose through authorized channel, if anyone tries to change some of the documents and all, it becomes difficult to really identify that. What happens in this particular case is the time sequence of various transactions which are happening in the ledger, they are maintained through various blocks in the blockchain. The ledger, whatever we are talking about, a distributed ledger, so the means you are maintaining a different nodes. At each node, what the ledger contains is a chain of blocks. Okay, what each of these blocks contains is nothing but a transactions which are carried out on some particular asset or some kind of what is a contract and other things like that. So it is a collection of sequence of chain of blocks, and each block contains a sequence of transactions. So here every block typically contains a hash pointer as a pointer to the previous block, a timestamp and transactional data. Suppose, see, there is the transaction from this particular peer, some amount is transferred to the other peer. A has transferred something to B. So this is the transactional data. Okay, so these details are maintained within the block. And another important thing with respect to the blockchain is that, see, whenever you maintain a chain, you have to make sure that you should be able to verify all the transactions in the chronological fashion, and it should be tamper proof. That's the basic idea of going for this one. So when you say that there is a link hash pointer which is a link to the previous block, I think most of you might be aware of hashing techniques, is it right? So in data structures you would have studied about hash algorithms, and at the same time in a cryptography you would have studied about hash algorithms like SHA-256, MD5 and all. So these are the algorithms. What they do is they take the variable length string as an input and give us a fixed length the code as an outcome. What is the basic idea of these algorithms is they help you to identify whether the data is intact or any modifications have taken place. So now here we have to make sure that after you added something in the blockchain, whether it is intact or any tampering happens and all. So here that is the reason. It's not that the integrity has to be maintained for the sequence of transactions within a block. It's not. It also required to maintain the integrity across the blocks in the blockchain. Is it right? The first block, then second block contains the transactions following the block one. That is how we have even the hash pointer as a link to the previous. Okay, the time at which it happened and also a transactional data. So it is resistant to modification of the data by design. Okay, so it is basically a distributed, it helps you to create a distributed ledger, and it is cryptographically protected. That's the beauty of this particular technology. It can serve as an open distributed ledger that can record transactions between two parties in a verifiable and permanent way. That is another thing. So at any point of time, if anyone want to verify, so the way in which the transactions have taken, you can verify that, okay, because it is maintained across all the nodes. Anyone can access that and try to verify the things. So it's managed between the peer-to-peer, adhering to the protocol for validating new blocks. Once recorded, the data in any given block cannot be altered without the alteration of all subsequent blocks. Okay, so it's not possible, actually, humanly possible to carry out these kind of changes in the blockchain because it is a cryptographically protected. So this is the way it is updated, chronologically it is updated. So we have block 1 created. After that, actually we have some kind of bifurcation. So block 4, block 2, 3, 2 chains are created. So similarly again, block 4 is forked again to the 2. So like the way we have the chain created. And if you look at it, within each of the block we have the transactions, is it right? So that is how they are all linked. Okay, there is a timestamp, the time at which each of these things are added, they are all added in this particular thing. And each of these blockchain is maintained at every node in the distributed environment where each of these peers are involved. So now here, one important thing is here, if you look at it, the transactional details, when we said the transactional details are going to store here, we may not store each and every document relevant to that particular transaction. All the documents, say, suppose let us say we have something called as the land record application. The seller and buyer, there are so many documents and all which are exchanged and other things like that. All the documents we may not be storing as part of this particular thing, but the integrity of all the details is maintained through the data structure called as a Merkle tree data structure. So, and the root hash code only is maintained within that particular thing. See now what this particular Merkle tree represents is the various data blocks corresponding to that particular transaction. The leaf nodes contain the data blocks corresponding to the transactions. Each of the intermediate non-leaf nodes holds the hash value of those data blocks, and finally let us say hash 0 and hash 1, its hash value is stored in hash 01 block, and then for the two children of the root, their hash is stored at the root. Okay, only the hash value of the entire Merkle tree is going to be stored there. Whereas the data blocks and all you can store in your routine database or a flat file system, you can maintain in an untrusted zone. But if anyone want to verify, they will get from this trusted blocks zone this root value, and they will try to get the data from the untrusted area, and then they will again compute the verification by applying the hash algorithm and check whether it is matching with the root. If it matches, then we can say that it is impact and it's not changed. Okay, so this is one of the beautiful data structure, so which you can be securely maintained, and then in a untrusted area, and only root can be maintained trusted, and it can be verified very easily. So this is something which is used in the blockchain. So BCT helps to create verification records for a digital. This is very important. What we are trying to do, what we are trying to put in a blockchain is nothing but fingerprints or signatures of the transactions we are trying to store in the blockchain. Actual transaction related details and all will go in the database. But the fingerprint, that is signature, the way you have your own individual identity to a signature, though transaction detail signature, which is the root of the Merkle tree, is stored in the database. That's what. So these fingerprints are stored in block and then linked in a chain of blocks where the subsequent block also has verification record. So this is the way it is maintained. So this is, you can go through later, this is a way, so the Merkle tree structure. So from data blocks, from the leaf, you move towards the root to calculate the hash value. So what is the purpose of this technology? So first we try to understand something about centralized and distributed ledger, then we move to understand blockchain. So blockchain is a shared distributed ledger. So it facilitates the process of recording transactions and tracking assets in a business network. Is it right? So anything, okay. So what all the things you can try to represent through the blockchain? An asset can be tangible, something like details of a house, a car, a cash, land, or intangible property like IPR, intellectual property such as patents, copyright or branding. Okay, so car, say like for example a vehicle, after it is released from the showroom, so it is moving across the various hands, the ownership can be tracked through this, the insurance details, license details of the owner, and in case if there are some accidents you can track through that, and also for every vehicle there is something like a lifespan, so you can maintain that and you can throw away once because people keep using that particular vehicle after that, and even you can track the payment of the toll gate, the vehicle movement and whether it has paid, all those tracks like that you can try to maintain. Virtually anything of value can be tracked and traded on the blockchain network, reducing risk and cutting costs for all involved. So this is first thing is the most important thing is whatever the asset you are talking about in the physical world, whether it is what is that, either a tangible or intangible. So it can be converted as a digital asset. You are trying to convert into a digital asset on which you are trying to carry out all the transactions. So and those transactions are going to be chronologically updated, verification and authentication with a permanent time stamping so that people cannot change it. and then they are distributed, because see, now this ledger on which the various transactions are carried out on the specific asset, this particular ledger, the same copy is maintained across all the nodes in that network. So distributed, and because of this particular thing, what happens is, suppose if a malware infects one particular system and then the ledger is corrupted, then immediately you can try to get it back from the other nodes in that network. Okay, and similarly, if there is a denial of service attack launched on one of the thing, the service will not come to the halt. You can retrieve it from the other nodes in the network. Okay, so and then cryptographically still, as I told you, the integrity of that particular thing is protected through the powerful hash algorithms. So it is very difficult to tamper and do that particular. So the silent features are the transactions happen peer-to-peer. There is no intermediary, and here you can see that it happens in near real time. The idea is, in the real world scenario, when you want to have a clearance for a check or anything like that, it may take a couple of days time. Is it right? Whereas here, there is no intermediary agent here. It is happening between the peers. So real time it is going to happen. It's a distributed trust. We don't have a centralized entity, and irreversibility and immutability. Okay, so you cannot change that particular thing. And there is something like a smart contracts. See now, for example, suppose whenever you are trying to sell a land or anything like that, there is some sequence of steps followed before the registration happen, right? So when you are initially signing the agreement, you agree for some payment of some X amount. Then after 3 months, you ask them to pay some other amount, and finally at the time of registration, you try to have that. All the steps involved in that particular contract, you can encode it as a smart contract as part of the blockchain applications. Okay, so that is how any kind of real world the transactions happening on the tangible or intangible asset, you can try to represent through the blockchain. Cryptographic guarantees distributed ownership, tamper resistant, and to pseudo anonymity. And while you are involved in the various transactions, you can protect your identity and involve. Okay, even that kind of the support exists in this particular case. So the current stage of evolution, if you look at it, see from 2008 onwards, like it is being used to create the virtual currencies where the financial transactions are happening peer-to-peer without involving the banks and all. So that is one thing. Then people started using, exploring for non-financial services around 2015-16. Now the banks are aggressively moving towards the piloting the various non-financial services. And then the expectation is by 21-25, blockchain is going to be the mainstream technology in various these things. So these are some of the various like platforms available. Like one is Bitcoin Core, Ethereum are some of the public the blockchain platforms. And Hyperledger from Linux Foundation, which is supported by the IBM and all, it is for permissive blockchain. So again here, there are types of blockchain. One is Bitcoin or Ethereum is something like, because see now what happened in the Bitcoin case, across the globe, anyone can be part of the Bitcoin network. Anyone can try to read or write to that particular blockchain, they carry out transactions. Whereas that becomes very difficult to manage, especially when you want to write to that, there is something called as a proof of work and other things, which is difficult to manage, the resources and other things. Whereas private blockchain is like, for a various government, the use case and other things, we can have the permissive blockchain where we can have a restricted number of entities who are going to write the blockchain. Instead of making everyone involved in writing to the blockchain, we can have a restricted number of people to carry out the write operation. So that is about multi-chain, the block stack, and even Hyperledger belongs to that. Consortium is something like where we can have a selected set of nodes. We can say that, okay, if these 10 people are trying to agree, then we can try to carry out the write operation and all. I'll just come back to this particular thing. So like that, we can have the different types of blockchains created. Yeah, so now the question is, see, we are telling that we can carry out the transactions and all. Now one most important problem in a distributed environment is that, so now these transactions have to be updated, synchronized across all the nodes without having any kind of issues. Is it right? Yes. So now for that actually, what is the mechanism? Like, is it, suppose it may be possible that same Bitcoin might be involved in 2 transactions. Is it right? So we need to avoid all those kind of things. For that, there is something like called as a consensus. Okay, so you have to make sure that all these people agree to this kind of transaction, then only you will be trying to update in the ledger of the database. So for that, what is that which is important is at every node, whenever it tries to update the block, the transaction, the block, it keeps a track of the status of the previous records. What is the state of the previous records? That is something which it has, and then Once it receives a new transaction to be updated or anything like that, then based on the previous things and what is the state it is going to reach, okay, they all agree upon that particular thing and then the update in the blockchain. So here there are two cases. There is something called as a proof of work. So what happens in this particular proof of work in the Bitcoin is that, so whenever anyone want to update something in the blockchain, he has to solve some kind of puzzle. Sure, he has to prove something and then he is given the privilege to, instead of anyone just like that trying to add, unless he completes that particular task, he cannot do that thing. But here it is computationally involved. You are going to waste lot of resources. Whereas in case of a permissive blockchain, there is something like a practical Byzantine fault tolerant case. What it does is, if some set of agents say that agree upon, okay, this is the relevant transaction or anything like that, then immediately the blockchain, the middleware will try to update in the database. So agree to the terms of some kind of the voting kind of thing. Okay, so that's the way it is going to happen. And the correctness at all the nodes, the exact same copy replication and all is implemented by the, guaranteed by the protocol rules which are part of the blockchain platform. And here also the entities who are involved, either writing or reading into the blockchain, they are identified using the public key cryptography, where they have a key pair and everyone is identified through their public key. So if you look at the application areas, you can use it in the governance. So like we have come something like a DigiLocker kind of thing where you are trying to store all the identities. Okay, so that can also be maintained through that. And land records application. Suppose for example, I'll tell you, Sweden is one country which is much ahead and they're come out with some almost 3 prototypes in implementing the land records, their land records using the blockchain technology. Because most of the time we keep hearing, right, there is some kind of fraud happened because the multiple registrations happen and other things like that. So here that kind of, double spending problem will not be there with the blockchain technology. So wherever you have these kind of problems, you can look at that. Banking and finance is another domain which is very active. So healthcare, because sometimes you need to maintain the privacy of the patients. At the same time, the details have to be shared from the hospital management, pharmacy, insurance people, like that, multiple, and even that is a lab, diagnostic labs. Okay, in all the cases, the people can exchange the patient records by maintaining the privacy through the blockchain. So media, smart cities, judiciary, insurance, like that, there are various domains. So if you look at the governance, we can improve the transparency because anyone can verify the blockchain. Is it right? Available. Prevent fraud because there is no central entity. So unless some major voting happens, then only you will try to add something to the blockchain. Speed up transactions, no intermediary, there is no clearance kind of thing, and establish trust. It's a distributed trust. Okay. So looking at the cyber security domain. Okay. So just give me next slide, please. Yeah. So actually, if you look at the cyber security, so these are the 3 core pillars of the cyber security. You all agree? Confidentiality, integrity, and availability. Okay. So first, the service should, the confidentiality has to be ensured, and the integrity, no one should be able to tamper or should be able to detect in case if some altering happens. And the another most important thing is first the services, whatever you are trying to access, it should be available to the end user. So, but people do all sorts of things by doing denial of service kind of attacks and all can be launched. So now here, so how the blockchain technology is relevant in cyber security. So it is going to be very, very relevant. See, one most important thing is in cyber security, see, like new technologies keep coming and the intellectuals are sometimes the so-called hackers or whatever it is. So they are the intellectual people. They keep trying for identifying the vulnerabilities or loopholes so that they can penetrate and disturb the system. So as long as you are in this particular area, in the cyber domain and looking for new technologies, whether it is IoT, cloud or whatever it is, big data. So the cyber security is an evergreen area, continuously new threats keep coming. And the people need to work for identifying appropriate security solutions for all those things. So we continuously keep doing, and blockchain technology can be a very, very common in enabling the cyber security in the near future. So here, blockchain can provide the transparency and auditing. Okay, it can include user identity security, transactional and community security, and the protection of the critical infrastructures. Here, it can help to realize more efficient and secure software development and supply chain risk management. See, sometimes we are worried actually. See, some particular software or hardware, whenever it is generated, it will move across various entities. So now the entire supply chain, the integrity of each of the item can be maintained in a blockchain so that the backdoors or anything which are introduced at each of the the subsystem, we will be able to track by making use of these kind of things. So, and enables us to make the most use of shared online services, eliminating the potential security and privacy issues. So we'll come back. Okay. So one is resolving trust. You all agree? One major problem, central entity which is used as trust, that is resolved with a distributed trust. Yes. Then transactions across the peers directly, transparency and accountability, whoever are involved, you are able to identify that particular person involved in the transaction through its public key. So he is accountable and it cannot be tampered.